With Martin Dolan, and you're from Oxford Brookes University, so you work for them, but you're working in partnership with Aquobex.
That's right. Yeah.
So could you tell me what you're doing today and why?
So today it's a proof of concept test to see what kind of a setup might be the most suitable for the property that we're trying to protect in Carlisle. We have two simultaneous tests which involve two separate wall panels and two different coatings internally. One is a polyurea coating provided by Adler and Allen, the other is a natural cement render. The idea is to test these, see that they work, and then we may be able to install them depending on the results in the house.
So what are you going to do? How are you going to test it?
So because the predicted flood level in the house is up to about 900 millimeters, we're going to try and simulate that by filling this tank here with 900 millimeters of water and subjecting that wall and render or coating to sort of simulated flood condition, testing then how much water or moisture passes through into the house. We'll also then do a second test after 24 hours, which will let the water in, sort of simulating the overtopping of any protective measures that are in the house. And we'll do a similar test whereby we'll measure the moisture content and the drying out times once we empty the tank.
That's the idea of the Showcase project, really, that we're not trying to permanently exclude water. We accept that water probably will get in extreme flood conditions, so we want the homeowner to get back in sooner. So even if it's not perfect and we know that the drying time is reduced, this will still pass.
Yeah.
But if it all fell to pieces, and we couldn't dry it quickly, then it would be a sort of big failure, wouldn't it?
Exactly. I mean, flood resilience is all about not necessarily keeping all the water out, but understanding that if water does get in, we need to be able to minimize the damages. And that can be reducing the drying time, selecting materials that are less prone to mold growth, just specifying details that don't allow for moisture to build up between layers, things like that.
The surveyors advised this test, and the reason they advised it was the fact that we could decide to use all these materials, put them into the house, and then a real-time flood happened and it failed.
Yeah.
So I don't think people realise just how much preparation is going on with this project, because I think they think, you know, we're going to make a house flood resilient, let's do it now. But we have to do an awful lot of pre-planning before we get on site.
Absolutely.
And this is a fine example, using an Aquobex tank and using your expertise and doing things in a scientific way. Doing that first will enable others that are doing it in the future not to go through all this rigmarole.
I mean, every house is different and every setup's going to be different. What is lacking within the industry is this sort of scientific evidence of what is the best solution for different types of construction. And by doing this test, we're hopefully, we're not giving a definitive answer for every property, but for this particular type of property, we can then build on that, and going forward we will know the best solutions.
Right, thank you. Let's go. Let's fill it up with water. So, Martin, I know this is a bit of a weird request, but can I ask you what you're doing now? Because this kind of information is going to be so useful for people that are doing flood resilient work in the future.
Well, so we're about to carry out the tests, but before we do that, I'm just checking the moisture content level of the blockwork and the render on the wet side, or the side that's going to be flooded, and then we can take a post-test measurement as well, which will tell us how quickly the blocks are drying out. And that's simply to have all of that data. While this test is not necessarily testing the blockwork, understanding those sorts of issues is really valuable for future research as well. Thank you.
So Martin, we're inside now, so we're on the imaginary home side. What's this? What's this? And what are these wires doing?
So what we have here is a setup whereby we're going to test two different wall finishes at the same time. So we have two separated wall panels finished with different wall finishes. On the inside of that then we've got a closed cell insulation, and we have taped it with a foil tape. which will seal all the joints and make it airtight. Because it's sealed and because we can't get any measurements behind the insulation while the test is running, we have installed some sensors behind the insulation, between the finish and the insulation, and we can then use these to measure the moisture during, after the tests. This will give us an idea of how much moisture, if any, is building up between the two layers, which can be a problem in a house where if it's sealed and you don't have ventilation and moisture builds up, it can cause damp and mold to grow.
So this will tell you after, will you check it what, tomorrow?
We'll check it periodically every hour during a 24-hour cycle, and that will tell us how moisture is building up, if any. After the test then we will remove the insulation and be able to see quite clearly what kind of moisture has built up. We have taken pre-test measurements across the wall. We also have sensors at the bottom of the wall which will tell us if any liquid moisture is building up there.
So what are the two different finishes here, the wall finishes that you put
So
on?
this grey rubber type finish is a polyurea coating which is sprayed on. It's really quite durable. It's not breathable, whereas this is a cementitious render which is used for tanking. It's applied like any other render. It is breathable, but we're going to test now to see which lets more or less moisture through.
Thank you.
Test sample here, we've been taking moisture measurements at fixed points up and across the board, so we can understand the take-up rate of water in the Dragon board. As you can see, it's not delaminated. There's no damage to the board at all. You can see from the surface of it there. And when we take measurements on the board here, we can see that the free space moisture level in there is back to where it was when we started the project. So now we're going to see what happens. We're going to take the panels off and investigate what's going on in the insulation layer and the covering that's on the outside brickwork. We've got the natural cement as the barrier to prevent the water coming through, with the solid insulation next to that. And if we pan round to the left, we've got the adrenaline material, whatever it's called, polyurea maybe, with the same insulation material on top of that. When we've taken measurements of moisture, we did see, in both instances, we saw water collecting at the bottom of both of them, but you can see that on both the insulation materials have not delaminated. Indeed, when we do water tests on it, there is no water within the insulation material. There's a lot of moisture in the natural cement here, and that's probably because it's a very dense material and will take a long time to dry out, particularly if the water's trapped within there. So we've got to look at how we actually put this sandwich together on these various houses to come up with the optimal solution. And that's going to be more of Martin's work as we carry on.